Measurement of three-phase power by 2-watt meter method. Here, the power in a three-phase circuit can be measured by connecting two wattmeters in any of the two phases of three-phase circuit. A wattmeter consists of a current coil and potential coil as shown in figure. So now this is the current coil and potential coil. See, observe this one, current coil and potential coil. Here the wattmeter is connected in the circuit in such a way that the current coil is in series and carries the load current, and the potential coil is connected in parallel across the load voltage. So the wattmeter reading will then be equal to the product of current carried by the current coil and the voltage across the potential coil, and the cosine of the angle between the voltage and current. The measurement of power is first given for a balanced star connected load and then for a balanced delta connected load. This is the balanced connected load. Here this is the star connected. See, observe this one. Here these are the loads Z A, B, Z A, Z B and Z C. Here this is the load in connected in star connection, and the W1, W2, these two are wattmeters, and the current coil here W1 wattmeter is connected between the two phases. That phases are A and B phase, and the wattmeter 2 is connected between the B and C phases. B is the common terminal, common phase for these two wattmeters here. So the voltage between the terminals A and B is AB, and A and C is CA, and B and C is EBC, and the current in A phase is IA, and the current in B phase is IB, and the current in C phase is IC. So now from this observation, the circuit shows a balanced star connected load for which the power is to be measured 2 wattmeter W1 and W2 are connected in phase A and phase C as shown in figure. Here see the phasor diagram here. EA, EB and EC. The resultant voltage between the EA and EB minus EB, or the resultant voltage between EC and minus EB. EC and minus EB result will be give ECB. EA and EB minus EB will be give EAB. Here this is the resultant current. The current coil of a wattmeter W1 carries the current IA, and potential coil is connected across the voltage EAB. Here the phasor diagram is drawn to determine the angle between IA and EAB as shown figure. From the phasor diagram, we determine that the angle between phasor IA and EAB is 30 plus phi. Hence, the wattmeter readings W1 is given W1 EAB IA cos 30 plus phi. And then the current coil of wattmeter W2 carries the current IC, and its potential coil is connected across the voltage, that is ECB. From the phasor diagram, we determine that the angle between the phasors IC and ECB is 30 minus phi. Hence, the wattmeter reading WT is given by WT is equal to ECB IC cos 30 minus phi. Here the line voltage is EAB, that is equal to ECB, and that is equal to EAC or CA, that is EL line voltage, and the line currents are IA, IB, IC and IL. From this 2 wattmeter method, EAB is equal to ECB is equal to EL, and line current IA is equal to IC is equal to IL. Hence, the W1 here wattmeter reading 1 is equal to EL cos 30 pi plus, and W2 the wattmeter reading 2 is W2, that is EL cos 30 minus pi. So here these two will get power of 3 phase. So we could add these two wattmeters, that is W1 and W2. So W1 plus W2, that is equal to EL cos 30 plus pi plus EL cos 30 minus pi. So from that W1 plus W2 is equal to EL to cos 30 cos pi. Cos 30 is nothing but root 3 by 2. Those values substitute in that, will get W1 plus W2 is equal to root 3 EL cos pi. From the above equations, we observe that the sum of the two wattmeter readings gives the 3 phase power. The above giving the 3 phase power reading, that is root 3 EL cos pi. Now go for balanced delta connected load. The circuit shows a balanced delta connected load for which the power is to be measured to wattmeter. W1 and W2 are connected in phase A and phase C is shown in figure. See, observe this one very carefully. The wattmeter 1 connected to phase A and phase B, and wattmeter 2 connected between the phase C and phase B. B is the common terminal for the two wattmeters. So here observe this one phasor diagram. The current of coil wattmeter W1, here is the current IA, and its potential coil is connected across the voltage EAB. A phasor diagram is drawn to determine the angle between IA and EAB. Here, say, observe this one. The EAB is along with x-axis, and EAB, EBC and ECA, these are displaced by the 120 degrees. So here the currents are IAB, IBC, ICA. Here the current, the line current IC is the resultant of ICA and minus IBC. This will give that resultant current of line current, that is IC. and here IA is nothing but line current, that is nothing but it is the vector addition of minus IC and IAB. Here observe this phase angle here. So EAB and IA is 30 plus 5 and EB and IC is 30 minus 5. The phase displacement angle is between the minus CBC and IC is 30 minus 5 and here EAB and IA the displacement angle is 30 plus 5. From this phasor diagram, we determine that the angle between the phasor IA and EAB is 30 plus 5. Hence, the wattmeter reading W1 is given by W1 is equal to EAB IA cos 30 plus 5. The current coil of wattmeter W2 carries the current IC and its potential coil is connected across the voltage ECB. From the phasor diagram, we determine that the angle between the phasor IC and ECB is 30 minus pi. Hence, the wattmeter reading W2 is given by W2 is equal to ECB IC cos 30 minus pi. Here, W2 is equal to ECB IC cos 30 minus pi is for the wattmeter reading 2. And the line voltage EAB is equal to ECB, that is EL, and line current IA is equal to IC is equal to IL. Hence, the wattmeter reading 1 is W1 is equal to EL cos 30 plus 5 and wattmeter reading W2 is EL cos 30 minus pi. Here, so by adding of these two readings W1 and W2, W1 plus W2 equal to EL cos 30 plus pi plus EL cos 30 minus pi. So here W1 plus W2 is equal to EL 2 cos 30 cos pi. So that is W1 plus W2 is equal to root 3 EL cos pi. From the above equations, we observe that the sum of the two wattmeters reading gives the three-phase power. Here, a determination of a real power, reactive power and power factor. Here, W1 is EL cos 30 plus 5. W2 is EL cos 30 minus pi. W1 plus W2 is equal to root 3 EL cos pi and W2 minus W1 is equal to EL sin pi. Now here from that, so here very careful observe this one. So read once again here, this is W1 plus W2 is equal to root 3 EL cos pi and W2 minus W1 is equal to EL sin phi. So here tan pi is equal to root 3 W2 minus W1 by W1 plus W2. From that we get the pi value. So pi phase angle, pi is equal to tan inverse root 3 W2 minus W1 by W1 plus W2. So here the power, three phase power P is equal to, it is wattmeter reading 1 and place wattmeter reading 2. That is P is equal to W1 plus W2. Q is equal to root 3 W2 minus W1. So here power factor is cos pi, that is equal to cos tan inverse root 3 W2 minus W1 by W1 plus W2. This is the about the power factor, and so observe this one. The power factor can also be determined from the power triangle. So actual power, that is Watt's power is, utilized power is P. That is along with the x-axis, and the Q is along with the y-axis. These two P and Q resultants will give the S. This from the power triangle. Phase angle is pi. Now P is equal to W1 plus W2 and Q is root 3 W2 minus W1. So here S is nothing but under root of P square plus Q square. So S is P square plus Q square. So what is that? P here W1 plus W2. What is Q? Root 3 W2 minus W1. Here S is equal to under root of W1 plus W2 square plus 3 into W2 minus W1 square. Here power factor or cos phi P by S. P is W1 plus W2. Under root of S is under root of W1 plus W2 square plus 3 into W2 minus W1 square. So here wattmeter readings at different power factors. At unity power factor pi is equal to 0, W1 reads that ELIL cos 30 plus pi and ELIL cos 30. Cos 30 is root 3 by 2 into ELIL. Now W2 is ELIL cos 30 minus pi, that is nothing but ELIL cos 30. That is nothing but root 3 by 2, that is ELIL. Here W1 is equal to W2. When pi is equal to 0, when pi, that means when pi is equal to 0, that means here phase angle is 0, unity power factor means W1 W2, the two wattmeters are showing same readings. At W2 is equal and the power factor is 0.866, that means cos pi is cos 30, that is pi is 30 degrees. Here W1 is ELIL cos 30 plus pi, ELIL cos 30 plus 30 means cos 60 here. Here 60 means it is half of 30 minus 30, that means it is cos 0 is 1. This is ELIL. Here W2 is equal to 2 into W1. 2 into W1. At power factor 0.5, that means pi is equal to 60 degrees. W1 is equal to ELIL cos 30 plus 5 ELIL cos 30 plus 60 equal to, that is equal to 0. Here at 60 degrees showing the 0, one of the wattmeter is showing 0, and W2 is ELIL cos 30 minus 5, that means here 30 minus 60, which shows the root 3 by 2 ELIL. Now power factor is less than 0.5, that means more than 60 degrees. Here W1 is showing less than 0, and W2 is reading more than 0. Now power factor is 0, that is pi is equal to 90 degrees. Here the pi, both are opposite, their readings are, the magnitude is same but the value is, the sign notation is different. So here W1 is equal to ELIL cos 30 plus pi, that is equal to ELIL cos 30 plus 90, that is equal to ELIL by 2. W2 is equal to ELIL cos 30 minus pi, that is equal to ELIL cos 30 minus 90, that is equal to minus ELIL by 2. That is equal to W1 is equal to minus W2, that is the, so at condition of power factor 0, pi is equal to 90 degrees. So this is the, so for from the, now go for one problem. A balanced three-phase delta connected, a load has for phase impedance of 25 plus J40 ohms. If 400 volts, comma, three-phase supply is connected to this load. So find, first one is phase current, second is line current, third one is power supplied to the load. Z phase is equal, here Z phase is here 25 plus J40. So once I can read this one. Once I can read this question, what they are given. Read carefully. Write the what they are given data. And think about how to do this problem. Now see, here Z phase is under root of 25 square plus 40 square, that is 47.17. Pi is equal to tan inverse of 40 by 25, that is equal to 60 degrees. Z phase is 47.17 angle of 60 degrees. Now EL is 400 watts, that is phase is delta connected, so EL is equal to E phase, that is 400 volts. Now for the first one, I phase is equal to E phase by Z phase, that is equal to 400 by 47.17 angle of 60 degrees, that is equal to 8.48 angle of minus 60 degrees. So now IL is equal to root 3 I phase, that is equal to root 3 into 8.48, that is equal to 14.7 angle of minus 90 degrees. Now P is equal to root 3 ELIL cos pi, it is equal to root 3 400 into 14.7 cos 60. So now P is equal to 5397.7 watts. This is a power in the three phase delta connected. So no problem to solve this one. 2 watt meter, so we will discuss later this one. So only problem one is so enough.